welcome. I think this is mechanics class number 55 or 56, part 2, I think lecture number 15. See the title. Last class, I told very clearly how to decide compression and tension. Earlier, we are doing Lami's theorem. So I stopped Lami's theorem in the earlier class. Last time was exclusively for deciding, or if a sketch is given, to decide whether it is compression or tension, or if you want to mark, how to mark compression tension. It is very important for structural engineering. Furthermore, we will come in strength of materials. How much required for engineering mechanics, I told. Now, right here, Lami's theorem continued. We will now continue Lami's theorem. Lami's theorem continued, and today will be concluding part. That is over. Everything will be over. From next class onwards, we are going for new part. Okay. Now, question 8. I remember first class 4, second class 3. Find tension in the two cables using Lami's theorem. Sketch given. Or they can tell cable or wire or string, rope, anything will do. Or the question can be given by words little more. A weight of 60 kN is acting through actually it's not weight, you can tell load. Weight means act vertically down. A load of 60 kN is acting at a point B where two cables are joined and connected. Other ends of cable are secured firmly there. What is the tension in the two cables? Sorry, T1, T2, I put later. Okay, over. This is a question. And remember, this is master question where you have to do all the calculation. After this one, 3-4 questions, I will give exercise for you. Okay, now, this is the question given. First start. You see, after that sketch, you should come here. You should correctly go in the same order as I tell. When you write, in the notes, order will be maintained. Let T1 and T2 be tension in the cable, partially rubbed out cable, BA and BC, because I am starting from B, as shown in the figure. Okay. Now, go back to last class. I will not explain or waste time. If someone has missed the last class, and if he tells, sir, not clear, means it is your problem. So, tension means what? See? This is tension in the cable here. If it is that way here, see? This way, and this is tension T1, correct? Yes, T1 in the cable BA, and this I will call T2. Okay, now, just for information, when this is going this way, see, there will be a reaction here. We don't require it. Reaction RA, which will be equal to T1, and there will be in reaction exactly in the same line, reaction RC equal to T2. We don't require it. Okay, now, we are considering joint B. Now, make a note. Now, we have to find T1, T2. You will consider equilibrium of joint B. Therefore, we require angles at B. Okay, start to find angles at B. See here. A here. See original sketch. A here, B here. A, B. Vertical height is 2.5 meter. Horizontal is, this is 5 given, this is 3 given. So this will be 5 minus 2 equal to 5 minus 3. 5 minus 3 equal to 2 meter. So suppose I call this angle as alpha 1, tan alpha 1 equal to 2.5 by 2, you get alpha 1. Same way, B to C is 3 meter given, and height is 2.5 plus 1.5, total 4 meter. If I call the angle alpha 2, tan alpha 2 equal to 4 divided by 3, you get alpha 2. Also, one more thing is there. Usually in such questions, they will give that load vertically down. Then angle not required. But I told master question that force 60 kN is not vertical, little inclined. Okay. For 60 kN force, see here, slope given 3:1, vertical 3, horizontal 1. Let it be alpha 3. If it is alpha 3, this also your alpha 3. tan alpha 3 equal to, or tan of, for any inclined line, if you consider angle with horizontal, tan theta equal, tan of the angle equal to vertical by horizontal. 3 by 1, you get alpha 3. Now, everything is ready. Now, I will do one thing now. I will rub the full board. Where I kept it, I don't know. I will rub the full board now and apply Lami's theorem. I got it. Okay, see. None of this required now. Even this sketch also not required. I remove it. Not required, correct? Yes, not required. See now, correctly. Now, consider equilibrium of that point P or joint P, I will tell. It's a joint B or point B. Okay. See here, B is here. One force goes this way. Oh, I forgot the force. Oh yes, I rubbed it. It is, luckily I saw it here. See, I should write here how much it is. It is 60 kilonewton. Okay. One force goes this way. See, this way. It is 60 kilonewton. If I draw a horizontal line here, this angle is 71.565 degrees. Okay, done. One tension going this way. See, angle is 51. See, unknown force. We are considering this joint. You should consider this arrow mark. Or when your load is, see, when you pull this way, tension goes that way. Tension T1. For this, the angle is 51.340 or 51.34. Zero not required. One more force, which is T this way, T2. For this, the horizontal angle is 53.13 degrees. 53.13 degrees over. Now, this is the joint B over. Therefore, everything over now. Now this solves. See, still remember, it is not ready for Lami's theorem. We just consider joint. Now, if you see there, you should write, it looks like ordinary problem of Lami's theorem. Nothing to be explained now. Because so much, this is question number 8. 7 questions, what you have done. Someone will ask, something is not clear, means I will tell 7 questions what you are doing. I don't know, sometimes this rubbing becomes difficult. That's why I always rub by pausing the recording. Okay, start. Now, this is ready for solving. Start. We will solve by Lami's theorem. Lami's theorem, you write. Okay, start. Joint B. Right here, consider equilibrium of joint B. Actually not required, right? Consider, already written, equilibrium of joint B. See. Scale is not maintained. T1, little steep it is. Okay, it is little steep. Okay. T2, and this is 60 kilonewton. This is the point B. Since you are solving a Lami's theorem, what you have to do? You require this angle, this angle, this angle, this angle. Now, I should not explain. I will dictate, you write. You should write this angle equal to 51.34 plus 71.565. 51.34 plus 71.565. 122.905 degrees. 122.905 degrees. Somewhere you show the calculation. This angle, this angle. This is 180. From 180, subtract 51.34, also subtract 53.13. 75.53 degrees. 75.53 degrees, show the calculation. Those who are serious. this angle. No, don't see 360 degrees. Calculate 53.13 plus this angle, or 53.13 plus 180 minus 71.565. 53.13 plus 180 minus 71.565. 161.565 degrees. 161.565 degrees is the sketch for Lami's theorem. Now write here, by Lami's theorem. Actually, now I should stop Lami's theorem. Unknown first. T1, okay, T2. T1 divided by sine of 161.565 equal to T2 divided by sine of opposite angle, sine of 122.905 equal to 60 divided by sine of 75.53 degrees. Is 75.53 correct? 1 minute, calculate. That is, 1 minute, we'll check the answer. How? 75.53 plus 122.905 plus 161.565. Perfectly 360 degrees. Now solving, now I should not tell. Use these two, therefore get the value of T1. Use these two, using these two get T1. Using these two get T2. 60 divided by sine of 75.53 equal to into sine of 161.565. 19.T1 plus 19.595 kilonewton and T2 60 divided by 75 point plus 60 divided by sine. That is the old habit. In the earlier calculator, you press the angle first, then press sine. I was used for that one up to earlier, into sine of 161.565. 19 point, once again I am doing same thing, 19.595. I am doing once again same, 60 divided by sine of 75.53 equal to into sine of 122.905. 52.025 kilonewton. Actually, I solved somewhere, I checked the answer. 52.025 correct, because I noted down, because to save the time, 19.595. Yes, correct, perfectly correct. Because I do not want any mistake. Now, solution is over. So, if you want, you can do one thing now. You can make a neat presentation if you want. See, if you want a presentation. Therefore, the tension in the two cables will be as shown below. You can write a sketch here. Presentation, if you want. B, A and C, T1, this tension is 19.595 kilonewton. This tension is 52.025 kilonewton. This is the final answer. Okay, now do one thing. For those who want to learn more and more, use this sketch. Don't use that sketch. Go for basic conditions of static equilibrium. I will just dictate, I will not write. I will not waste time writing same thing again and again. See, some disturbance. Sigma Fx0, right side positive. Okay. Minus T1 cos 51.34 plus T2 cos 53.13 minus 60 cos 71.565 equal to 0. Equation number 1, sigma Fy0 plus T1 sin 51.34 plus T2 sin 53.13 minus 60 sin 71.565 equal to 0. Form the two equations and solve it. T1 will come 19.595, T2 will come 52.025 over. Now, I will prepare some extra question for solving. That all briefly, our main part is over. Now, question 8 and 9, it is for you to solve. Brief answer. Find tension in OA and OB. Angles are given. Oh, thank you very much. Direct answer. See. First you put the sketch here. See, I told you how to solve when you practice. First you write the sketch. Then write one more sketch where you mark tension. Never use the same sketch for marking. Because why? Subject will not be clear. This is the tension. Okay. This is, I will call one thing. So T1, T2, this is the tension at O for A. I will change the language. This is tension at O for OB. That is tension BO, not required for us. Okay. Now it is your choice. See, TOA, TOB, 400, 40, 45, get this angle, 95, get this angle, apply Lami's theorem and solve. If you want, use this sketch and solve by equilibrium conditions. Okay. Question number 9. Find tension in the two wires supporting the given load. Once again distance given, but one thing, last time see these are different level, now same level. Okay. 2, 4 and 2.5. First angles, see. This is 2. This is 4. This is 2.5 given. So that is 1.5. If I call alpha 1, tan alpha 1, 2 by 2.5. Tan alpha 2, 2 by 1.5. Get the two angles. Then question mark means you have to get the angles. Put the sketch. This angle, 180 minus alpha 1 and alpha 2 together, from 180, subtract sum of alpha 1, alpha 2. This angle. See, 90 plus alpha 1. This angle. 90 plus alpha 2. Apply Lami's theorem and get. But before that one, you put the sketch once again, second time write, and show clearly the tensions. In the question it is not given, but right here, T for OB, not OB, sorry, see, this time it is T for AB, T for AB and T for AC. Oh, see, I wrote usual habit, T for AB, okay, T for AB and T for AC. Solve all these questions. Okay. Now, not much left. Class is very short. I can start new one. No. Let me finish everything for Kani's method. Sorry. Not Kani's method, Lami's theorem. See, Lami's theorem I use for engineering mechanics. Kani's method I use for structure analysis. I use the word Kani's method maybe 1,000 times more than I use the word Lami. Lami comes only for engineering mechanics. Kani comes everywhere. See, by habit, see, sometimes this is not a technical mistake, speech mistake. Okay. Suddenly, NI means what comes to mind? Kani. Kani's method. Okay, now, question how much over now? Oh, see, question forgotten. Today started from 7, 8, 9. I don't know the question number only now. Okay, leave it. 2 extra questions right here. 2 extra questions. Extra questions. Completely for you to solve. See, one question. Same way. Very simple. See. 450 Newton. This is 30 degrees. This is 30 degrees. Over. Find tension in the 2 wires. I will not give any answer. See, put equilibrium here. this tension, this tension, this tension, see. And 450. Then 90 plus 30 is 120. 90 plus 30 is 120. 180 minus 30 is also 120. Oh, all three angles are equal. There is a rule. At a joint, if there are three forces acting and angle between all the forces are same, then all three forces are of equal magnitude. Therefore, this is 450 Newton. I will call this as T1. This I will call T2. Right here, T1 by 450 by sine 120 equal T1 by sine 120, T2 by sine 120. Your T1 will come equal to T2 equal to plus 450 Newton will come. Plus 450 Newton. Solve the question. Then, next question. A force is applied here. See, how much? 20 kilonewton. One member is supporting. Now it is not cable. See, this way you cannot place a cable. You can suspend something by a cable. If you put this way by cable, gone. Okay, now, this way. A, B, C. Now I will give angle directly to save the time. This is 40 degrees. This is, say, 50 degrees. Okay. Find axial forces in BA and BC is the question. Using Lami's theorem. Just a minute. I'm running short of ink. I have to change the ink actually. I will try other pen. Okay, now do one thing. Make a note. When you apply a force this way, the two members will be compressed. So you should write a note. Therefore, make that much common sense required. See, when you apply a force this way, those members will get compressed. So right here, the two members, it is not cable, some rigid members, solid members, the two members will be in compression. Let compression I told, this way. Write one more sketch actually, don't use the same sketch. Let C1 be compression in this member, let C2 be compression in this member. Now see, now here reaction will come this way, reaction will come this way, not required. Now consider equilibrium of joint B. Load of 20 kilonewton, one compression comes this way, C1, and one more compression this way, C2, 40 degree, 50 degrees. See, this is 40, this is 50, so this angle equal to 90 degrees. If this is 50, this also 50, 50 plus 90 is 140 degrees. This, first of all, I should not tell all these things. If this is 40, this is 130 degrees. Correctly get the value of C1, C2 by Lami's theorem, answer. And one more thing. See, all forces are incoming now, or acting towards the joint. Yes, Lami's theorem, what is the requirement? All should either act away from the joint, or all should act either, or it should act towards the joint. Okay, now answer. 20, why should I divide by sin 90? 20 into sin 130 will give you that answer, C2. 15 point plus positive will come, 15.321 Newton. 321 kilonewton, not Newton. Kilonewton, see, I wrote kilonewton here. That also important. Kilonewton. This is C1, I put here, C1. Okay. And C, other one will be 20 into sin 140. 12.856 kilonewton. If you want, solve by equilibrium condition by forming simultaneous equation, then you have to use this sketch, not this sketch. If you are using by equilibrium, you want this angle. Okay, solve it. I think sufficient. Now, further more question, I will write in the notes. And one important, one small note you have to make. So far, in all, it's very important note. See, in the notes I will write it. So far, when you apply Lami's theorem, we got everywhere positive answer for the unknown. In case you get negative sign for the answer, nothing to worry. What it means, that the answer is negative. If they, in the question, if they give the arrow mark, answer is negative. But what it means that force is not in that direction, it is in the opposite direction. This you are knowing it. In the notes I will put extra questions there. So now I will wind up Lami's theorem. Next class I am going for, I have not decided now. Okay, some more equilibrium questions are there regarding contact points. I will cover few questions. See, I cannot cover all the questions required for academic year. That we will see later. Extra questions for academic purpose. But what I will do is, when I write the notes, what I do is, I add extra questions there, so that it is useful for everybody, those who are preparing for competitive examination, those who want to learn the subject, that is to get structural knowledge in design field, or those who are writing academic examination. Here, what all subject point of view require I have covered. Okay, we will meet in the next class. Thank you.